Hello and welcome. My name is Partho Majumdar. So far in the program, we have discussed many models using which we can make predictions. However, this is just the tip of the iceberg. There are so many more models which has already been created, and there are so many more models which people like you will create in the future. Also, we will see that combining the models that we have discussed, we can create innumerable number of models. Now, the most difficult part is to select a model that will predict the outcomes in the future reliably from the data that is available to us. We will discuss this aspect of predictive analytics in this video. Now, you must realize that what we are doing is traditional programming. In traditional programming, we write programs to which we input the rules and the data. So the rules and the data are inputs to the program. Using the rules and data that we have provided to the program generates the answers. So this is traditional programming. You would have realized that we are picking up a model and then we are giving the data, applying the model on top of the data, and we are getting answers. So what we have been doing is basically traditional programming. In the part 2 and part 3 of this program, we will see a different paradigm which we know as the machine learning. In machine learning, we have programs. However, now we input the answers and the data. Based on the answers and the data that we input, the program generates the rules which it will use in the future for predicting on the data that is supplied to him. After this short detour, let us continue on the topic of our discussion for this video. That is, for a given data set, how do we select a model? We will go straight to Excel for continuing this discussion. So now we are in Excel. We will use the same data that we have been using so far in this program, and we will try to select a model which best fits this data. So I am creating a new worksheet with the same data. Let's start our hunt with trying moving averages method. Within moving averages also, actually we need to try different values of n, that is moving averages for different number of days. However, as this is just illustration, we will only find moving averages for one value of n, that is n is equal to 9. This number 9 has been chosen arbitrarily. This needs to be chosen with experimentation. So now we find the moving averages for 9 days. So we come to the 10th day and find the average for the previous 9 days, as this is the simple moving average. So there we have found the moving averages for 9 days. Now we find the residual. Residual is nothing but the difference between the actual number of printers ordered minus the predicted number of printers to order. We find the square of the residual. We copy this for all the observations. Next, we find the sum of the squares of the residuals. We can use this value of sum of squares of residuals for comparison. We make a summary sheet where we record the performance of each of the methods that we will try. The first method we have tried is simple moving averages. We will track the sum of squares of residuals and the R square where it is applicable. Now we are ready with this illustration. We now move to the next method. We will use central moving averages. Again, we will take central moving averages for 9 days. So first I create a new worksheet with the same data. We name this worksheet as central moving averages. To find the central moving averages for 9 days, we need to go to the 5th day and find the average for 4 values above and the 5th day value and 4 values below the 5th day. Now we calculate this value till it is possible to compute the central moving averages for 9 days. As before, we find the residual and we will also find the square of the residual because we want to compute the sum of square of residuals. So in know that residual is the actual value minus the predicted value. So we got the value of sum of square of residuals. We see that the sum of square of residual is reduced quite drastically from the first method that we utilized. Next, we will find the weighted moving averages. So we create one more worksheet. Here we'll rename this to weighted moving average. So we will find the weighted moving average for 9 days. We first assign the weights. So we will give simple weights of 1, 2, 3, 4, 5, 6, 7, 8, 9 for the 9 days. We sum up the weights and try to find the multiplier. So there we have found all the multipliers. Let's just verify that the multipliers, that is the case where the sum of all the multipliers is equal to 1. Now we find the weighted moving averages. We will take the central weighted moving averages. So we use sum product. We'll anchor the multipliers. Now we have it. We copy this for all the values where it is possible to find central moving averages, central weighted moving averages. As before, we will find the residual and the sum of the squares of residuals. So we need to find the square of the residuals also. We will make some space for that. So we find the residuals and the square of the residuals. There we have the sum of the squares of residuals in the case of central weighted moving averages. So we'll put this in the summary sheet. So we tried three models of moving averages on the data. We saw that we got the smallest value for sum of square of residuals when we used weighted moving average. Now let us try the regression models. Now we will try regression models. We start with level regression. So we create a new sheet. We'll name this level regression. We will use number of printers to order as the dependent variable, and we will use amount spent on school supplies as the independent variable. So we'll go to data analysis toolkit. We'll choose regression. We'll give the Y range as the number of printers ordered historically, and the X range as the amount spent on school supplies. We'll select output area. So there we have the result of the regression. So notice that we have got a R square of about 56%. And notice the sum of squares of residual. This has come down drastically from the moving averages methods that we were using so far. So we will record this in our summary. Now let's move to the next method. Next we will try the level log regression. So we create a new sheet for that. So in level log regression, the level is the y remains the same. However, we have to take the log of the x value. So we say natural log of x we can find this by using the ln function. So you say ln the amount spent on school supplies. So now we conduct a regression between number of printers ordered and the log of amount spent on school supplies. So there we have the output. So we take the value of r square for comparison and also the sum of squares of residuals. We will conduct the log level regression. In log level regression, we have to take the log of the y and x remains as it is. So we take the natural log of y using the ln function. Now we create our regression model. Here the y's will be the column F and x will be the column D. So there we have the output. We take the values of r square and SSRSID into the summary sheet. Now we try our fourth regression model, that is log-log regression. So in log-log regression, we have to take the log of y and the log of x and make a regression model from log of y to log of x. So we create a new sheet and try this out. So our sheet is ready. Now we create our regression model. We take the known y's as the column F and the known x as the column G. There we have the output. We track the values of R square and sum of square of residuals. So we have applied 3 models using moving averages method and 4 models of linear regression on the data that we have got. Now let's try a few more models which are polynomic, and then we will also try a model which is a hybrid between polynomic and logarithmic. So here we are back in Excel once again. So we now try to create a model where y is equal to a times x square plus some constant and error. We will call our model x squared. So as a first step we find x squared. Here x is the amount spent on school supplies. Now we create a regression model using data analysis toolkit. Where y is the column B, the printers ordered, and x is where we have x squared. there we have the output. We capture the value of r squared and sum of square of residuals for analysis. We try one more model. Here we take y is equal to a times x plus b times x squared plus some constant plus some error. So this is a polynomial regression. So this is a polynomial in degree 2. So here we require y, then we require x, and we require x square. So we find x and x square. Now we do the regression between y, x and x square. For x, we select the column F and G. So we get the output. You notice that the r square is marginally better as compared to when we made a model with y is equal to x square. We capture these values in our summary sheet. Now we try one more model. Here y is equal to a into x plus b into x square plus c into x cube plus some constant plus some error. So this is a third degree polynomial. So we find x, x squared and x cubed. Now we form our linear regression model. You see that the R square is further improved, though very marginally. Take a look at the sum of square of residuals of the three models we just tried. Now we will try a last model where we will take log of y is equal to a times x plus b times x squared plus c times log of x. So you can notice that what I am trying to do is that I am trying different models and trying to find out which model fits the data the best. So this is the experiment which requires to be done no matter what is the data provided to you. No model will fit the data immediately. There is a lot of experimentation just to be done to come up with a model which will fit the data properly and which can be used for making reliable predictions. So now we need to find log of y x, x squared and log of x. And check the equation once again. You can find the log of y by using the function ln. We copy the formulas for all the observations, create our data set for regression, and now we conduct the regression using data analysis toolpack. Y is in column F. And X are in column GHI. There we have the output of the regression. You notice that this model is better than all the other models we have tried so far. So we have to keep trying different models till we come to the model which is most appropriate. There are other criteria also which we will discuss later in the part 2 and part 3 of the course. The main purpose of this video was to elaborate the point that we need to try a lot of models before we can come to the conclusion which model we will use for our prediction of data from a data series. That concludes our discussion. Thank you for listening.